So composition of limits tends to be the hardest, like the most challenging limit property to kind of wrap your head around and to use appropriately. And there are some tricky spots to this. So the composition of limits says that if the limit as x approaches c of g of x is equal to L, then the limit as x approaches c of the composition of f of g of x, you can pull that composition out so you can kind of put the limit on the inside, right? So we can kind of put the limit on the inside first and take the limit of the inside function. And then notice that the limit of the inside function is L, and that becomes what we're taking the limit towards of the outside function. So the tricky part here is that you sometimes have to check the left and the right limits. So we want to be careful here. Especially for piecewise functions. So need to take note of the left and the right-sided limits. And another thing that you want to be careful of and watch out for is when you take the limit of the inside function, you want to notice whether or not it approaches that value from above or below. So we want to take note of whether it approaches that limit value for the inside function from above or below, because sometimes we need to use that for the outside function to say whether or not we're actually taking the limit from the right or the left. And like I said, this is going to be really important for piecewise functions. If you're doing the composition of continuous functions, it doesn't matter quite so much. So let's get into a couple of examples. So given we have this cubic function for f of x and that g of x is the linear function negative 2x, we want to find the limit as x approaches 2 of f of g of x. So the first thing we're going to do is take the limit of the inside. So we're going to take the limit as x approaches 2 of g of x. Now, because g of x is a continuous function, we don't have to worry about the left and the right so much. So we're just going to say, well, that's negative 2 times 2, so we're going to get negative 4. So now when we go to take the limit of the outside function, we're going to say, okay, well, the limit as x now approaches negative 4 for f of x, right? And again, because f of x is a continuous function, a polynomial, we don't need to worry about left or right-sided. So we're going to just plug it in. So we got negative 4 cubed minus negative 4 squared plus 4 times negative 4 minus 1. So it's going to be negative 64 minus 16 minus 16 minus 1. So let's see, that's negative 64 minus 33. That's going to be negative 97. So our overall answer here is negative 97. So we're going to get into doing some with graphs because I think this is going to help show the left and the right-sided piece a little bit better. So we're going to use the provided graphs to answer the limit questions below for f and g. And we're going to do all 4 of these questions. So we're going to take first the limit of f of g of x as x approaches 3. So the first thing we want to do is take the limit as x approaches 3 of g of x. Okay, so if we scroll out and look over at g of x, we have it as x approaches 3. Okay, so our function is continuous here at 3. Right, so our limit value there is going to be 1. So because our function is continuous, we don't need to worry about the left and the right side there. So we're going to get that this is equal to 1. And then we're going to take the limit as x approaches now 1 of the outside function. So again, scrolling out to see that graph. Again, we have at 1, it is continuous there, and we are down at 2. So our overall limit is going to equal 2. change the size of my highlighter for the next question. Okay, so now we have the opposite. We have g on the outside of f. So now we're going to start with the limit as x approaches -1 of f of x. Okay, so at -1, f of x is continuous. So we have -1 here. So that's going to put me down at -6. And then I'm going to take the limit as x approaches -6 of my outside function. So at -6, right, we can't actually see what's happening on the g graph, so we need to be able to kind of extend that graph. So, right, because that's -5, so like -6 is like out here. So we know that for g of x, right, this is, okay, we have the point here, -1, 3. Right, our slope, if I go down 2 over 1, so our slope is going to be down 2 over 1, so -2. So my function for that is going to be y minus 3 equals -2 times x plus 1. It's the equation of that line piece right there. Right, so now I'm going to plug in -6 for x, so I get y minus 3 equals -2 times -5. So y is going to equal 13. -13, right? -2. Oh wait, it's positive 2x. Hoop. So -10 plus 3, we're going to get -7. There we go. I'm going to say that makes much more sense. So our overall limit here is going to be -7. Right, and you could also do that by like counting off your slope there. You could just kind of extend the graph that way. So now let's get into these down here. So we have the limit as x approaches 1 of f of g of x. So if we look at 1 on the g of x graph, right, if I go ahead and get my first step set up here, right, if we look at 1 on the g of x graph, right, we have a discontinuity there. We have a jump discontinuity because we jump from 2 different y values. So this is an instance where we need to take the left and the right-sided limit. So we're going to take both sides. Okay, so as we approach it from the left, right, we are approaching down to -1. Now, as we're approaching -1, if you notice on the graph, we're coming at -1 from above it. So for our second step here, right, this is going to instantly translate to the limit as x approaches -1. Now I'm approaching it from above on the inside function, so that means I need to take a right-handed limit for my outside function. So let me re-explain that again because it can be a little confusing. So because the inside function is approaching, on the left-hand side, is approaching -1 from above, when we take the composition, that's going to translate to saying we're going to really take a right-handed limit for the outside function. So the direction that you're approaching it, when you have to take one-sided limits for the inside, the direction you're approaching it from helps to translate to the outside. So now as I take -1 from the right, I'm approaching down to -6 here. And now we're going to do the other side. So on my inside function for g of x, as I approach 1 from the right now, I'm approaching -3 from above. So that means I'm going to take the limit as x approaches -3 from the right for f of x, because we're approaching -3 from above on the inside, so we're approaching it from the positive direction. So we're taking it from the right, and so if I go over and take -3 from the right, we're also approaching -6. And then because both of these are the same value, our overall answer here is going to be -6. So we're going to do the same sort of thing on the other function. So here we're going to have the limit as x approaches -3 of our inside function f of x. So -3, it's right here, we're approaching -6. right? And so this one's continuous at that point, so we don't have to worry about it so much. Then we can just go straight ahead to our outside piece. So I thought this one was going to be like the last one, but I was wrong. So -6 of g of x, and we